Section 1.1, Statistical and Critical Thinking. The process involved in conducting a statistical study consists of prepare, analyze, and conclude. Statistical thinking involves critical thinking and the ability to make sense of the results. It demands so much more than just the ability to execute complicated calculations. Data are collections of observations, such as measurements, gender, survey responses, things like that. Statistics is the science of planning studies and experiments, obtaining the data, organizing, summarizing, presenting, analyzing, and interpreting the data, and then draw conclusions based on them. A population is the complete collection of all the measurements or data or items that are being considered. This is the whole collection of things that we're interested in making inferences about. A census is when we collect data from every member of the population. A sample is a sub-collection of the members selected from a population. Let's take a look at an example. In a journal article that was recently published, it was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. In this case, the population and the sample are as follows. The population is the 38 million detectors, all of them, in the United States, and the sample is the 30 that were randomly selected and tested. The objective here was to use the sample data as a basis for drawing a conclusion about the entire population. And here's a little graphic that shows those three steps we mentioned earlier: prepare, analyze, and conclude. Let's take a look at some data. This is information on pleasure boat registrations, and this is in Florida, and then the manatee deaths, and this is over a number of years. We see for each of the years the number of registrations of boats and the number of manatee found fatalities. And the context is the information provided in the data table. The format suggests there's some kind of a relationship. Is there a relationship? That would be the goal we'd want to talk about. The source of the data was from the Florida Department of Highway Safety and Motor Vehicles for the registrations of the boats, and then the Florida Marine Research Institute gave the information on the manatee deaths. And these appear to be reputable sources. The sampling method, these were taken from official government records known to be reliable, and this may not actually be a sample. These may actually be the total population counts. Voluntary response bias, or self-selected sample, is one in which the respondents decide whether to include themselves or not. When we see this in a sample, in a survey, let's say, we wonder about the validity of the information. So the following are types of polls that are common examples of voluntary response samples. Internet polls, where people online can decide whether to respond. Mail-in, where people decide whether or not to reply. Television call-in polls, where newspaper, radio, or television announcements ask you to voluntarily call a special number to register your opinion. The bias here is that people select themselves to be in the poll, and by the nature of that, probably people who are interested in the topic tend to participate where others who are not offering their response. Example, Nightline users asked viewers to call in with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call in, and 67% said the UN should be moved out of the United States. Now again, that was a voluntary response sample. In a separate independent sample, where the subjects were randomly selected, only 38% wanted the UN to move out of the United States. So we can see the difference in the response that we get when we have a true random sample versus a voluntary, or what we call a convenience sample. Two polls provided dramatically different results. So analyze. After completing the preparation by considering the context, source, and sampling, we're going to analyze. We can graph and explore. We can apply statistical methods, and these are the things we're going to learn about in the course. The final step is the conclusions, and we should develop an ability to distinguish between statistical significance and practical significance. Statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. Sometimes you use a different level there. We might use 1% or 10% depending on the situation. For instance, getting 98 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result by random chance. Getting 52 girls in 100 would not be significant because this could easily occur with random chance. Practical significance is it's possible that a treatment or finding is effective, but common sense suggests that it's really not very practical. So here's an example. ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender they desired. In the absence of any evidence of effectiveness, the FDA banned the product as a gross deception of the consumer. Suppose the product was tested with 10,000 couples who wanted to have girls, and they got 5,200 girls. This result is statistically significant because the likelihood of it happening due to chance is only 0.003%. But so chance doesn't seem like a feasible explanation. But the practicality here is that the rate went from 50 to 52%. And the reason that it was significant back here, I want to point out, is because of the large sample size. But the practicality here, if you were a couple and you were told you could increase your risk or chance of getting a girl from 50 to 52%, and the product was quite expensive, you might not want to be willing to do that. So misleading conclusions. When forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. Sample data reported instead of measured. You want to make sure the data that you're working with is something that was actually measured rather than asking people to self-report. Example would be if you're working with weights and you ask people to self-report their weight, people tend to under-report their weight. Loaded questions, if survey questions are not worded carefully, the results of the study can be misleading. And also the order of the questions, they can be put in a certain order to generate a certain type of a response. A non-response occurs when someone refuses to respond or is unavailable. Non-responders may be different than those who do respond. And percentages, some studies will cite misleading percentages. Note that 100% of some quantity is all of it, but if there's references made to percentages that exceed 100%, those references are often not justified. Let's take a look at an example. Is there a potential bias here? An article in this journal noted that chocolate is rich in flavonoids. The article notes, quote, regular consumption of food rich in flavonoids may reduce the risk of coronary heart disease, end quote. The study received funding from Mars, the candy company, and the Chocolate Manufacturers Association. So is there a bias there? Yes. Notice who funded the study, the candy company and the Chocolate Manufacturers Association. What's wrong here? In a US Today online poll, 951 internet users chose to respond and 57% said they would prefer drinking bottled water instead of tap water. This is a voluntary response sample, online survey. Cannot say that the sample is really representative of the whole population. Sample is probably not representative, as I mentioned, of the larger population who have a water preference. Statistical versus practical significance. Most people have IQ scores between 70 and 130. For $39.99, you can purchase a program from this company that claims to increase your IQ score by 10 to 20 points. The product claims to be the only proven IQ increasing software in the market, in the brain training market. But the author of your text could find no data supporting that claim. So let's suppose these results were obtained. In a study of 12 subjects using the program, the average increase was 3 IQ points. There's a 25% chance of getting such results if the program had no effect. Statistical significance? No, because there's a 25% chance of getting those results. Practical significance? Well, the IQ score only went up by 3 points, and the company's claim was 10 to 20 points. So we don't see practical significance here in addition.